All right, tonight we're going to learn the final piece of this sequences in series mini unit. We're going to be talking about what a series is. The key vocabulary here is series. What does it mean, and how is it different from a sequence? And this is a typo here. This should say series. But what we're going to be doing is we're going to be evaluating a given series for a sequence. So series is really, it's just a quick way of writing a summation. And it'll specify what I want from that summation. So if I say I want to know the sum of the terms 1 through whatever n is of this sequence, some sequence a sub I. What I'm really doing here is I'm saying I want to plug in a 1, I want to plug in a 2, I want to plug in a 3, a 4, a 5, all the way up to n, whatever n is, and I'm going to add all those together, right? In a series, you'll start with 1. So what this really is that I've just drawn here is this is a series n of a sub I. So instead of me saying, please sum all the numbers from 1 to 10 of this function, what I can just write is s sub 10 of that function. And it means the same thing. All right, and the reason you guys are going to see that we're using this is because there are some quick shortcuts, and it's going to lead us into some very quick addition, and we're going to learn how to do that very quickly. So let's talk about the first arithmetic sequence that we're given here. In an arithmetic sequence, one thing that we know is that we're using addition or subtraction when we go from one term to the next, and that's very important. So we're going to evaluate the series that is defined by summing the first 10 terms. So that just means evaluate s sub 10 of a of n. And in order to do that, what I'm going to have to do is I'm going to have to sum terms 1 through 10 of a of n. That's what that means to do. So s sub 10 just means the series from 1 to 10 of that function right there. So what that's going to look like is we're going to start off, it looks like, with negative 2 as our first term, and our second term would be 1, and then we would have a 4, and we would continue on like this, and eventually we would get up to the number 25. And unless you've found a faster way, the only way for me to get up to this 25 is to have done the previous number plus 3, the previous number plus 3, plus 3, plus 3, 10 times. All right, so I'm going to add all these things together. Now I could manually do negative 2, plus 1, plus 4, plus 7, and just keep going like that. Or I could use this quick addition, this format that always works for when we're quickly adding an arithmetic series. So let me just write it over here to the side in case we didn't get to it in class or in case you didn't quite understand it in class. Let's just say we have this sequence right here. This is arithmetic, and we know that because we can see that from one term to the next, we're just going up by 4. The sequence would be 1, 5, 9, 13, 17, 21, but I guess what I'm drawing here is a summation, right? Because we're adding all those together. Okay. Through 6. If I want to add all those things together, there's a much faster way to do this. And I know that because all of these numbers are going up by the same amount, what I can actually do here is I can add these two together. 1 plus 21 is 22. And that's a really important number, because if you check these other ones, what's 5 plus 17 is also 22, and 9 plus 13, 22 again. And that will always happen, actually, with an arithmetic sequence. You can take the first term and the last term, add them together, and that is exactly the same sum that you'll get if you add the second term and the second to last term, or the third term and the third to last term. And so since we know this, what we can actually do is we can just say, let's add the first term plus the last term, and then we'll just multiply it by half of however many numbers we need. Which makes sense in this example, right? Because if I have 6 numbers here, and I add pairs of them together, pairs of them each time, then I only need to do 22 times 3, because I'm adding the numbers together and making pairs. So what I can really just do here is I can just say this is 3 times 22, 66. So the sum of all these numbers right here should be 66. And that's much quicker than me doing 1 plus 5 plus 9 plus 13. And it might not be as quick if you only have like 4 numbers, but if we've got 50 or 100, then using this trick is going to save us a lot of time. So let's use it here. I'm summing 10 terms, right? So when I'm pairing these up, what I'm going to think about is I'm going to add my first term and my last term. Okay, that gives me 23. And based on what we just saw, if I add the second term and whatever the second to last term is, that should also give me 23. And the third term and the third to the last term should also give me 23. So the question is, how many 23s am I creating here? Well, if I'm pairing them all up, then I'm going to have half as many as the number of terms in this sequence. Since I'm going from 1 to 10, there are 10 terms in this sequence, so I just need to do 23 times 5. 115. And feel free to check that math if you'd like to do it the long way. But when you're adding an arithmetic sequence, this always works. It's very quick and very easy. Geometric, not so much the same. So consider a geometric sequence where we have a of n being defined by 4 times the previous term, and the first term is 2. So we're going to evaluate the series defined here by summing the first 6 terms of this sequence. So our series looks like this. And if I'm going to evaluate this series, then what I need to do is sum from n equals 1 to 6, because that's what that 6 means. I'm always starting at 1 with a series, and I'm ending at whatever is defined by the subscript of a of n, which it looks like is going to come out to 2 plus 8 plus 32, and we keep going, keep going. What I'd like to do is find all of the terms in this sequence and add them. But there is a shortcut for geometric series. I'll just write the formula here. It might be a little confusing at first. So we're going to take a of 1 and multiply it by 1 minus whatever the continuous rate of increase or decrease is to the nth power over 1 minus r. I'll explain this formula more in class. I hope we've touched upon it already, but if we haven't, on Monday we'll spend a lot of time doing this. All right, so this is only for geometric. This is a very quick way to sum a geometric series. So what I want to do here is I want to figure out what is a of 1, right? That's the first part of this. So if I'm going to find s sub 6, the series from 1 to 6, I need the first term. They've told me that the first term is 2. So I'll start here. Then I'll do 1 minus whatever it is that is the continual rate of increase from one number to the next. And let me show you what that rate is. I go from 2 to 8, that is times 4. If I go to 8 to 32, that is times 4. And if I keep doing this, it will keep being times 4, times 4, times 4, obviously, because look at our formula, which says that it's going to be 4 times the previous number. Okay? So that's r is 4, n is 6, because that's how many terms I'm summing together here, all over 1 minus 4. If you use this formula, you will be able to sum any geometric series very, very quickly. It's the comparison, it works the same way as the formula we just used with an arithmetic series. And if you evaluate this by plugging this into a calculator, you'll eventually get 2,730. Feel free, if you would like to add one number at a time all the way up to the top number, which I think is like 2040 or 2048 or something like that. So if you add all those together, you should get the number 2,730. If you don't, tell me in class, but I'm pretty sure this works because this is the formula for summing a geometric series. All right? We will talk more about how to use both of these formulas because I don't want to sit there and do manual addition anymore. We're going to start using these to make that much quicker for us. Okay? I will see you guys on Monday.